I demonstrate how to train an agent, intelligent agent, to learn how to approach this goal using Unity ML agent and PyTorch. Okay, so to start, I will place the agent very close to the goal to make the task easier. It's just like training a kid. You have to let them learn the elementary school material and then go to the junior high school, and eventually to college. If at the beginning you make the task too difficult, then it will become very difficult to train. So to start, I will start from a simpler training task, and then I connect to my environment. I go to Unity, hit play. Now I'm connected, and then reset. Okay, to start, I will fill the memory with some training material. Okay, now I finish. Now I start to train. Okay, to start, I train for 300 epochs first. Okay, and I print out every 10 epochs. So let's see. Okay, so now it's 10, already 10 epochs. This is how it looks at the middle, while I have already trained 190 epochs. Okay, I'm almost finished, already trained. As you can see, the agent seems to learn. So I close the environment first and then plot. Okay, here shows the reward and the number of steps. As you can see, the steps is gradually reduced and the loss function. Okay, now I go back to Unity to move this a little bit far away. Okay, make it so you can see how it looks like in 3D perspective. Now I connect to the training again. And reset environment. Okay, I already have memory in my batch, so I don't need to fill it again. Now start. This time I don't want to train 300 epochs. I reduce to 200 epochs. So now I'm going to train another 200 epochs. Okay, this is how it looks like at beginning. This is how it looks like at the middle when I train 100. As you can see, the agent already learns how to approach the goal. So I just wait till this training finish. 150, 60. Okay, almost finished. Okay, close the environment again. Take a look at the training performance. As you can see, the reward becomes steady and the number of steps is reduced and the loss function. Okay, I go back to the Unity to make the task harder, more difficult. Take a perspective view. Okay, now go back to Unity, connect to the environment, to the simulation environment again. Reset. Okay, skip the memory because we already have memory, and run the training again for another 200 epochs. Now the task become a little bit difficult. As you can see, the agent starts to lose its direction, but then it gradually learns. So I just wait. Oh no, no, now it seems it is learned because I'm using transfer learning. So the neural network accumulate past experiences and used to uh, used to solve the more difficult task. Okay. Now I already trained 150 epochs. As you can see, the agent starts to learn how to approach to the goal. As it learns the skills, it takes more time to finish each epoch. Okay, so 180, and then so it takes longer to finish. Uh, okay, and I'm going to close the environment again and plot the reward to see. Okay, now suppose I finish the training and then I can save my neural network and load the weight to a new uh, neural network and to test its performance. Okay, so now I'm going to connect to the environment again to test the performance of my neuron. I just run it 10 times. This time I remove the learning process, just use the neural network to control the agent. So as you can see, okay, the paths are exactly the same because I removed the learning process. Okay, to take a look at because I removed the learning process, so the reward and number of steps are the same and close. Okay, that's pretty much explain how I train the agent to learn how to approach to the goal through Q-learning.